Hello, and in this video, which is going to be the final video, we're going to look at estimating the area under a graph, or between the graph and the x-axis. And there are two key points. The first is that if you've got a curve and you want to find the area below it between the curve and the x-axis, then one way of estimating that is to, rather than using a curve, so rather than using the part which goes over here like that, it's not the best diagram, let's try again. So using this bit here, instead of using that, we're going to use this straight edge here, which we'll call a chord, joins 2 points of the curve together. And using that chord, we can then create this area here, which is ever so slightly less than the area that would be being asked for, but which would be very straightforward to work out the area of, because we know that we can find this using the area of a trapezium. And then the second key point here is that we know what the area of a trapezium is. The area of a trapezium is half the sum of the parallel sides, so this side and this side, added together and halved, which would effectively get you the average length of the parallel sides multiplied by the distance between them, which we'll call h for height. So using those two things, we can get an estimate for the area between a curve and the x-axis. And the easiest way for me to show you that will be through some worked examples. So let's get straight onto some worked examples. Okay, so we're shown the curve 3 subtract x, 2 add x, and we're asked for an estimate of the area in the region from x equals 0 to x equals 3, so basically everything that's shaded on the diagram. And they've also told us here to use 3 strips, each of width 1 unit. So we know that our strips are going to have edges, or trapezia are going to have edges that look like this, and we need to just create so I should do my strips at the edge as well. And you might notice, by the way, that the final strip here is going to be a triangle, not a trapezium. So there's the triangle. Then we've got this trapezium and this trapezium. This particular trapezium is actually a rectangle. Now, we've got the equation here, which means we can get these exact y values just in case they aren't integers. They look like integers, but we won't know that until we substitute and double check. It could look like that on the graph, but that could just be an approximation. So we should just double check those values using the equation. So if I substitute 0 into here and 0 into here, I get 3 multiplied by 2. 3 multiplied by 2 is 6. So we can see that to start with, we've got a value of 6. If I substitute 1 into these two places, I get 3 subtract 1, which is 2, and 2 add 1, which is 3. So I get 2 multiplied by 3, which is again 6. So this value is 6. Now if I substitute the value 2 in for this value here, if I put 3 subtract 2 into here, I get 1. 2 add 2 is 4, and 1 multiplied by 4 is 4. So this point is 4. And then the final point is when the x value is 3. And you can see that this first bracket, if x is 3, this first bracket is going to be 0. 0 multiplied by anything is 0. So this value is 0. So now we need to work out the area of the 3 strips. Now, there's a few different ways you could do this. If I do what we often do in A-level, it would just be to say I'll use that same formula for the area of a trapezium. So half h into A add B. The h for each of these is 1, so I'm going to have half multiplied by 1. And then I've got A add B And then we've got 3 strips, so I need to do this 3 times. And the first one, we've got 6, add 6. The second one, we've got 6, add 4. And the last one, we've got 4, add 0. So this is going to give us... I should put an approximately equals to here because we know we're not finding the exact area. This is going to give us a half of 12, add a half of 10, add a half of 4, which is 6, add 5, add 2, which is 13. So that's one way of doing it. We could also have said this is a rectangle, a trapezium and a triangle. For the rectangle, I've got a height of 6 and a width of 1. So 1 multiplied by 6. For the trapezium, I would need to do half the sum of the parallel sides times the distance between them. And for the triangle, half base times height, I've got a base of 1 and a height of 4. So that's a half times 1 times 4. So that's 6. Add a half times 10. Add a half times 4, which is 6. Add 5. Add 2, which is again 13 units squared. So you can see that we get the same answer. And then the final thing is, if you look at the first way that I did this, so if you look at this, you can see that we've got a half times 1, a half times 1, a half times 1. And so we could just have that at the start. And then we're going to need to put these heights in. The lengths, but we need to be careful. This 6 and this 4 are used twice, whereas this 6 and this 0 are used once. So we could do something like this to try and speed this up a bit. We could have the 6 and the 0 once, and then the 6 and the 4 twice. And we can see here that all of those things got added up in these brackets. The first 6, because it was the left edge, once. The 0, once, because it was the right edge. The second 6 and the 4, both twice, because they were in 2 separate shapes. The right edge of the rectangle and the left edge of the trapezium for the 6. The right edge of the trapezium for the 4. As well as the left edge of the triangle, also being 4. And if I evaluate this, then I get a half brackets. So 6 add 4 is 10. I'm going to deal with the brackets first. 6 add 4 is 10. 10 multiplied by 2 is 20. 20 add 6 is 26. So I get a half multiplied by 26, which is 13 units squared. So there's 3 different ways of getting to that same 13 using the diagram. Okay, on to the example 2. So this time we've got a shaded area which is not between the curve and the x-axis, it's between the curve and another line. Now they've asked us to use 3 strips. They haven't given us the equation of the curve, so this time we are going to have to read off the values. Now I'm going to do this in 2 separate ways. I've done the same slide on the next page so that I've got enough space here to show you both ways properly. So the first way I'm going to show you is if I were to work out the area under the curve, or an estimate for the area under the curve. So that's effectively the same as saying, imagine that all of this was shaded. And then once I've got an area estimate for that entire curve, which is going to include 3 strips that look like this. So working out the area of those 3 strips, then I can subtract the area of the blue trapezium at the bottom, and that will get me an estimate for the area of the shaded part of the original diagram. So we'll do that first. As I said, we don't have the equation of the curve, so we can't use exact coordinates. So we'll have to read off the graph, and so I'll label these on here. So this looks like 7, this looks like 12, this looks like 13, and the final point looks like 4. So my 3 trapezia look like this. They all have a width of 2 this time. So the area is approximately, that's area including large trapezium, is approximately equal to a half multiplied by 2, and then we've got 7 add 12, add 13, and 13 add 4. So that's so half times 2 with each of those brackets is 1. So all I need to do now is work out the brackets in each one. So 12 add 7 is 19. 12 add 13 is 25. 13 add 4 is 17. So we've got 44 add 17, which is 61 units squared. Then that's obviously got this extra part at the bottom that we don't want. So area of the large trapezium is half the sum of the parallel sides times the distance between them, which is from 4 up to 10, so that's 6, that's this distance here. So that's 3 multiplied by 11, which is 33 units squared. And so that makes the shaded area 61 subtract 33, which is 28 units squared. So that's one way you could do that question. Now we're going to look at a separate way to do the same question. So again, I'm going to use 3 strips of width 2 like they asked me to, but this time what I'm going to do is I'm going to be doing strips that look like this. So I'm going to work out the area of these 3 strips and add them together. And again, I'll need these values, so 7, 12, 13, and 4. So I'm also going to need these values here. So this is 6, and this is 5. And so on the first shape, I've got a triangle. And this triangle has a base of 6 and a height of 2. So I can use half base times height. So base of 6 and a height of 2. Then the second shape is a trapezium. And the trapezium has 2 parallel sides whose lengths are 6 and 8. And the height of this trapezium is 2. And then the final trapezium has, sorry, this is not a trapezium, this is another triangle, has a height of 2 again and a base of 8. So height of 2, base of 8. And so I can work these all out. A half multiplied by 6 is 3, 3 multiplied by 2 is 6. 6 add 8 is 14. 14 multiplied by half is 7. 7 times 2 is 14. And half times 2 is 1. 1 times 8 is 8. So I get 6 add 14 add 8, which is 28 units squared. And if you think back to example 1, we can actually do this particular method in a similar, quicker way by noticing that we've got a half multiplied by 2 in each one of the 3 calculations. So then all I need to do after that is think about the extra bits. And the extra bits, once again, have bits that are used twice because they're the right edge of one shape and the left edge of another. So these 2 bits are used twice, and this bit is used once. So the 7, sorry, not the 7, the 0. This had no height, and the 0 here had no height. These were used once. So we've got a 0 and a 0 at each end. And then we've got 2 lots of 6 and 2 lots of 8. And so I can do 6 add 8, which is 14. 14 times 2, which is 28. So we've got half times 2 times 28. And of course, a half times 2 is 1, and 1 times 28 is 28. So there's another way of doing that same method, but with a slightly tidier calculation to make it a bit slicker. So there are effectively 2 or 3 different methods for finding the area of this shaded section. And hopefully those 2 examples 1 and 2, will enable you to do the practice questions. So now you should be able to have a go at all the area under a graph questions on the document, which will complete the work that you've been set.